Hi, I'm Rob Davis, the founder of Advanced Threat Analytics. I wanted to walk you through a quick demonstration of how ATA automates and augments your existing security processes using our turnkey threat management platform. ATA focuses on managed prevention, threat detection, and response. We leverage the cloud to enable visibility and protection both on and off your corporate networks. Our platform is built on our Security Orchestration console, developed completely in-house by ATA developers. ATA provides immediate value because our orchestration console is completely integrated with best-of-breed tools from Cylance, Carbon Black, and OpenDNS. ATA has pre-built threat analytic plugins and security playbooks from a team with decades-long experience dealing with major cyber attack investigations. These plugins allow the user or security analyst to view process trees, virus total results, command line information, and many other details required to analyze security events. What makes ATA unique is that we customize the processes for each client. This turns thousands of security events per day into just a few incidents to investigate. Due to the tools we have deployed, each incident typically takes only a few minutes or even less to evaluate. ATA Security Orchestration Console is a centralized investigative workbench and case management platform to anchor your security operations process. Let's take a look at a day in the life of an ATA client. As we go over to the Security Orchestration Console, we can see incidents. In this first example, we can see an incident and there's multiple security events actually in each incident. We'll scroll down to look at something that looks a little bit more normal. We can see here there's an unsigned network connection on a production laptop. When we view the path, we can see that it's connectwise.exe. Let's drill in and take a look at this incident. We can see the path, the command line. If we expand to look at more details about the incident, we can scroll down if we can see that there are network connections being made, and also that this is an executable that's making a digitally unsigned connection. When you look at cyber attacks, in many cases, people will download executables that make network connections but are not digitally signed. This is always something that's good to take a look at and investigate as a security analyst. First thing we'll do is take a look at the process tree. As we drill into Carbon Black, this is using SAML for single sign-on. We can see that this is connectwise.exe. We can look at the command line for additional information. Most important thing is I want to verify where are these network connections going. We can take a look at that very quickly, and what we can see is that as expected, this is going to ConnectWise. This appears to be a very normal activity. What we want to do though is we don't want to be alerted about these types of events anymore. And within the Secure Orchestration Console, there's two ways to accomplish this. The first is we can create a filter. And we'll call this ConnectWise. And we'll do this for Carbon Black, but this could be for Cylance or OpenDNS. And we want to catch any versions of ConnectWise because ConnectWise updates commonly. And we'll look for path matches ConnectWise, and we can have some flexibility and make this a regular expression. We want to keep track of the incident for future reference, and we can test our filter to make sure it matches any events. As we scroll down, we can see that there's lots of events matched. We really don't want all these events creating incidents in our console. We could just click activate the filter, and the filter has been saved. We will no longer have incidents created based on ConnectWise type events. Now, another approach we could do is if this was an executable, we could simply whitelist this one executable. We could select this event, we could add it to whitelist. What we can see here is this MD5 hash has been added to a whitelist. We will no longer see this. We have some good intelligence in the console. It notices that all events were closed and prompts us to automatically close the incident, which we will go ahead and do. Now that the event is closed, we can go back and look at other incidents that were open. Maybe we can find something a little bit more interesting. This is Microsoft Windows that has a command exe process opened, something that isn't normal necessarily. We'll look into this incident. What we notice is there are 12 events. What the orchestration console has done is grouped all of these events together into one incident. As we scroll through, we can see different types of events. The first event here is WinWord or Microsoft Word. And we can see that Microsoft Word is opening a command.exe, something that isn't necessarily normal. As we scroll down, we can see some other interesting things. BCD edit, changing the boot configuration options, probably not something that most users are doing. We can also see that the shadow copy is being deleted. Looks like something maybe from CryptoLocker, and we can see that there are some new executables, device properties.exe, that are making network connections and registry changes. In my opinion, this is something that is definitely looks malicious. Let's do a little bit more investigation. So first thing we'll do is drill into the process tree. And what we see very quickly is Microsoft Word opening a command shell, which is calling Windows scripting host. And if we look at the command line, this is something that definitely does not look normal to me. The Windows scripting host is then calling a Visual Basic script, which is launching some temporary files, and finally our device properties files. It looks like this is the executable, device properties.exe, that has almost 10,000 network connections. That's typically something that is trying to find a command and control host. Since those get shut down very quickly, it's pretty common for CryptoLocker to try to connect up to many different hosts to ensure that it can get a connection. Just quickly looking at this, it's something malicious. What we can do is isolate the host. If this was CryptoLocker or a compromised machine, we want to make sure that no one else can use this machine as a launching point to either infect other machines, encrypt network shares, or make their way using lateral movement toward more important assets. Now the machine is isolated. If we wanted to, we could even go real time to the machine, look at running processes. On the machine, we could pull back different network connections, look at task schedule, anything we want to do in regards to more forensic type analysis and response, we'd be able to do real time on the machine. As you can tell, we're very quickly able to go from a security incident to, in one case, determining that one event was benign, which we filtered and whitelisted to make sure we'd never see it again, to another event that is actually very malicious. We're able to quickly verify that, isolate the machine. We can confirm that there's an infection. And with the built-in workflow, we could actually assign it to an analyst, or alternatively, we could escalate it to someone else on our incident response team. In regards to notification schedule, you can create different groups based on time of day, how you want the routing and escalation to work. Very, very useful, if you have events, and not only to respond to them, make comments, upload screenshots, but also have the workflow that allows you to route security incidents to different personnel on your team. Our design and deployment processes enables organizations to get started in just a few days to have a fully operational and orchestrated security system versus months and months of trying to do it yourself. The steps that we take our first client customization. This process takes usually several days and involves filtering out and whitelisting security events that are normal for your organization. If you do this properly, if something malicious occurs, this is the needle in the haystack that becomes very, very apparent if we have the normal events filtered out for your organization. Typically, we expect to have 10 to 20 events a day, but for most of these events, the investigation time should be in the minutes. So maybe 10, 15 minutes a day spent filtering out normal events. The rest of the time can be spent either hunting and investigating for things that could be malicious. The workflow process is very, very important. You want to make sure that users' notification schedules are set up to allow you to have workflow to operationalize the tools inside your environment. ATA has this at no additional cost, added in to these best-of-breed tools. Training is also very important. Something that we can offer is very sophisticated on-site training to make sure that the organization, our clients, have access to all the administrative consoles and can use the tools effectively protect their environment. Thanks for watching and have a great day.